Hi pre-calc students. Today we are going to talk about the binomial theorem. And this is really just a quick shortcut for expanding binomials. So we are using something called Pascal's triangle to help us do that. So first we're going to start by looking at Pascal's triangle. So we look at what we have so far. We've got a 1 at the top and a 1 and a 1. So you can see all the outsides are 1s. Then we have a 2 in the middle. Then we have 1, 3, 3, 1. If we wanted to try to guess the next row, well, we got a 1, 4, 6, 4, 1. So if you want to try to think for a minute about how we're coming up with each row, if you look at this part here, I'll just get rid of this. I'm just trying to get rid of that. There we go. So if we look at the numbers here, 1 and 1 add up to 4. We could look at this. 3 and 3 add up to 6. If I go down a row or even a couple of rows and kind of look at the pattern, 1 plus 5 is 6. 10 plus 5 is equal to 15. So that being said, kind of looking at the pattern, we know that the whole outside is always going to be 1s, and that we can find the numbers in the next row by adding the two numbers above. So 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 30 is 70. And then it just tends to go backwards. 7 plus 1 is 8. And again, we have a 1 at the end. Okay, so that pattern continues. And we end up with Pascal's triangle. Now I'm going to show you kind of a bigger one because this continues going down, but I won't show you the whole thing now. Before we talk about expanding binomials, I also want to point out the rows. So we actually start out by calling this row 0, and this is row 1, this is row 2, row 3, row 4, row 5, 6, 7, 8, etc. Okay? So that's Pascal's triangle. All right. Now we're going to go back to expanding. Now usually when we expand these, we multiply by hand. So if I were going to do x plus y squared, that's x plus y times x plus y. I would multiply these out. So x times x, x times xy, y times x. Now y times x is the same as xy. It's just like 2 times 3 is the same as 3 times 2. So it doesn't matter what order you put the y and the x in. And then y times y is y squared. And if we simplify that, we end up with x squared plus 1 plus 1 is 2. And this is y squared. And if we think about what the coefficients are for those, if there's nothing in front, it's a 1. So this is 1, 2, 1. 1, 2, 1. Okay, now we're going to do a y plus 3 raised to the third. So y plus 3, x plus y, x plus y, x plus y. So when we multiply these, we would start by just doing, multiply that out first, completely multiply that out, and then take the answer to that and multiply by x plus y. Well, we already know, just based on what we just did, that this is equivalent to this. Okay, so instead of taking the time to multiply that whole thing out, I'm just going to write down what we got the first time. It's either 1y squared or y squared, doesn't really matter. And now we're going to multiply that whole thing out. So we'll go x times x. X times x squared is x to the third. 2x squared y. Xy squared. Yx squared. 2xy squared. And y to the third. Okay, we'll simplify that. So we'll combine any like terms. If I look at this, this is 2x squared y, and I put that together with 1x squared y, right? Doesn't matter which one is first, but then I get 3x squared y. Okay, xy squared, remember there's an implied 1 in front of that. That's the same as 1. And 1xy squared plus 2xy squared is 3xy squared. And finally, we're left with this y to the third. Now, if there's no coefficient, we assume there's a 1. And once again, if I look at those coefficients here, I get a 1, 3, 3, 1. Okay, so now for the question of, do we notice anything? Do we notice anything with these answers? Well, if you look at this first one here, we have 1, 2, 1. Here we have 1, 3, 3, 1. If we go back and look at Pascal's triangle, here we have 1, 2, 1, 1, 3, 3, 1. Okay, so we end up with the coefficients of Pascal's triangle. Now notice the 1, 3, 3, 1 is kind of in the same spot as the line that has a 3 in front. That has a 3 in front. Whereas this one is in front of the one that has a 2 in front. And that relates to the degree. So basically we're going to use the numbers on the left for the degree of the binomial. So a degree of 0, anything to the 0 power is always 1. Anything to the first power is going to just be itself. But then again, if we raise it to the second, the coefficients are going to be 1, 2, 1. If we raise it to the third, it's going to be 1, 3, 3, 1, right? So coefficient raised to the third, 1, 3, 3, 1. Raised to the second, I got a little funky there, is 1, 2, 1. All right, so multiplying them out when we just have x plus y squared or x plus y to the third isn't too terrible, but it gets pretty awful if we have to do something like x plus y to the fifth. That's a lot of multiplying. So this is where the binomial theorem comes in. It's a shortcut for multiplying this whole thing out. And these are going to be the steps for doing that. So, once again, we're going to put, this is a 0, 1, 2, 3, 4, 5, 6. So you can see this is the Pascal's triangle continues on from what we had before. I'm going to label all the rows. Hopefully we don't have anything to the 16th, but if we did, we've got the coefficients. But first thing we're going to do, we're going to make a little grid. We're going to take the coefficients of each term. We're going to get that from Pascal's triangle. So again, if we're talking about being raised to the fifth power, we're going to go to this one here. We're going to take the coefficients of, it's going to be for each of the terms. And then we're going to take the x and the y. So I say the first term. It's really the first part of each term is raised to the highest degree and goes down to 0. Whereas the second term, the second term in the binomial is going to be raised to the 0 and go to highest degree. Then we simplify. All right, so we're going to do coefficient, and we're going to do the first part and the second part. Sometimes I just say first term, second term. Technically it's not term, it's just part of a term. But I'm going to take those coefficients. So the coefficients are 1, 5, 10, 10, 5, and 1. All right, now it says first term is raised to the highest degree and goes down to the 0. So the highest degree is 5. So I'm going to start with that x because that's my first term. First term is x here. And I'm going to go x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, x to the 0. Now the second term is raised to the 0 and it goes to the highest degree. So the second term is positive y. It's going to be y to the 0, y to the first, y to the second, y to the third, y to the fourth, and y to the fifth. Okay? And finally, we are going to simplify that. So we'll simplify that. Let's see if I can zero in a little bit more on this. Okay, and then when we simplify, I'm going to multiply all this out. So this is 1 times x to the 5th times y to the 0, which is the same as 1. So I'm doing 1 times x to the 5th times y to the 0 is 1. Then we're going to go plus, so this is where this first term comes in. I want to highlight that. Do the next one, 5. So we get 5, x to the 4th, y to the 1st. Next one is 10, x to the 3, y to the 2nd. Maybe I'll highlight this one more time and then we kind of get the picture. All right, next one, 10, x squared, y to the 3rd, 5, x, y to the 4th. And this last one is 1 times 1, because it's x to the 0, times y to the 5th. So it's going to be, I'm trying to squeeze it in, y to the 5th. All right, I'm going to change my mind just so we can see it a little easier. Highlight this, and highlight this. And finally the blue. All right, and that's just about it. I'm going to just clean it up one more time because we don't need all those ones. That 1 times x to the 5th times 1, that's just x to the 5th. I don't need that exponent of a 1, so I can just leave it a y. All right, 10 x squared, y to the 3rd. 5x, y to the 4th, y to the 5th. And there we go. So even though this takes a little bit of time, it's nothing compared to taking y plus, or x plus y, and actually multiplying it out 5 times. Okay. I think we'll go ahead and skip this one. I'll put it in the notes, but I think just if you want to see one more example, so in the hard copy notes, I'll put it in there, but just for the sake of time, and plus we're going to do another one, but it's just a little bit different. If we're looking at this one, we'll use the same process. It's just that we are not going to, we don't just have numbers that have x's and y's, we've got coefficients as well. Okay. So this is still to the 5th power. So I'm still going to do this thing 0, 1, 2, 3, 4, 5. So that's to the 5th power. You know what, maybe I'll change it to the 6th, just to have something a little different than we had last time. So this will make this to the 6th. So we're going to go here, actually. All right, that's the 6th row. So now when I do my coefficients, come on here. When I do my coefficients, I'm going to have 1, 6, 15, 20, 15, 6, and 1. And again, I'm going to make a little grid. So it's first term, at least first item within the term, second item within the term. So this is the first. We're going to now take 2x. So we're taking this whole 2x. And we're going to go from the highest degree down to the lowest. So now we're going to go with the 6. So 2x to the 6, 2x to the 5, 2x to the 4, 2x3, 2x2, 2x1, and 2x0. And for the second one, we're going to take the second term, which is positive 3y, and we're going to go from 0. y to the third, 3y to the 4, 3y to the 5, 3y to the 6. That 5 should actually be on the outside. y to the 5. All right, and then once again we have to simplify this. So the simplifying is a little bit more complicated. So I'm going to start it with a 1, but then this 2 to the 6. So 2 to the 6 is 2 times 2 times 2 times 2 times 2 times 2, which is 64. And then x to the 6. And then 3x to the 0 is just 1. But now this is our whole first term. We'll go back and simplify that later. Let's go on to a different color here. All right, so this is 6 times 2 to the 5th is 32. And then this is 3y. Might get a little dark, but it's okay. Try the next one. All right, we get 15. 2 to the 4th, 2 times 2 times 2 times 2 is 16, x4. 3 squared is 9. Okay, let's see if we can squeeze this in here. So this is 20. 2 to the 3rd is 8, x to the 3rd. 3 to the 3rd is 27. All right, so you kind of get the idea. If there's a coefficient in front, you need to make sure that the exponent applies to that coefficient as well. So this is 15. 2 squared is 4. 3 to the 4th is 81. All right, and then this is 1 times 2x to the 1st times 3y. So 3 times 3 times 3 times 3 times 3 is 243. And it's y to the 5th. Back to yellow, I guess. Or, yeah, maybe, I guess go back to blue. And finally, 1 times 2x to the 0 is 1, so that's 1 times 1. And 3 to the 6th. So 3 to the 6th, I can either use the caret key or I can do 3 times 3 times 3 times 3 times 3 times 3, but we get 729 y to the 6th. And that's the last term there. All right, so now we just have to simplify all that. We get 64x to the 6th. 6 times 32. 6 times 32 times 3 is 576. x5y. 15 times 16 times 9. So some of the numbers are getting pretty big. 2160. 20 times 8 times 27 is 4,320. And that is x to the 3rd, y to the 3rd. If I go to the, well, let's see, that was the green. That's green. And this is going to be pink. So 15 times 4 is 60. And 60 times 81 is 4,860. And that's x squared, y to the 4th. Look at the blue. Two times 2,432 is 4,864. And it's x, y to the 5th. And finally, no calculations. Okay. So trying to kind of match up the colors here. That is the very long final answer. And I know it's like, that doesn't seem like much of a shortcut, but it is way shorter than writing that whole thing out. Okay, I just have 2 more problems to show you. So if we have x plus y to the 10th, but we only want to find the 7th term. So if we just want to find the 7th term, I'm going to just go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that part is just like before. This is the 10th row. But I'm not going to make the whole chart, right? So maybe we still start a coefficients, a first term, a second term. But since I only want to go to 7, when I do that 10th row, I go 1, 10, 45, 120, 210, 252, and 210. Because 2, 3, 4, 5, 6, 7. This is the 7th term. That's the 7th term. So there's no reason to go beyond that. Now, if I'm doing the first term, remember I go from the highest exponent and I use the first term. So I'm going to go x to the 10, 9, 8, 7, 6, 5, 4. I'll stop right there. Make sure it's an x. And then with the y's, I'm going to start at 0. 1, 2, 3, 4, 5, 6. And there we go. All right, so that's the 7th term. The full 7th term is 210 x to the 4, y to the 6th. Just to look at one more of those, and this is the first one we've had with a negative, so this applies to when you're writing out the whole thing too. You have to include the negative when you're raising it to a degree. So here, if it's the 4th term, this is the coefficients, and this is the 1st term, 2nd part, I guess, but yeah, it's, well, anyway. And this is to the 8th. So again, we'll go 0, 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th row. This is a 1, 8, 28, 56. Now I could go on from there, but I just want the 4th term. I don't need anything else. Now I'm going to take 2x, I'm going to go to the highest degree. So this is 8, 7, 6, 5, and then with the negative, I want to include the negative. I'm going to start with 0, 1, 2, 3. All right, but this is what I want to calculate for the 4th term, is this whole item here, which is 56. 2 to the 5th is 32. Negative 5, and I should have written it like this. It's the whole thing raised to the 3rd. So this is negative 5 to the 3rd is negative 125. Y to the 3rd. And now in my calculator, because I can't do that in my head, we're going to go 56 times 32 times negative 125. And it's x to the 5, y to the 3rd. So obviously if we had to write this whole thing out, multiply that times itself 8 times, and try to find the 4th term, well, this is obviously a much quicker way to do that. So that was using the binomial theorem, using Pascal's triangle as part of the binomial theorem to take a shortcut when we're expanding binomials. And remember, binomials are two terms.